Okay, we're going to continue with graphing rational functions. And so this one will look very similar to some of the other ones, but we'll still discuss them. And so I've got this one, horizontal asymptote. So we talked about this. The degree of the numerator is 2 here, and the degree of the denominator is 1. So the top is bigger than the bottom. So whenever that's the case, we always say that that would be a none. So it doesn't have one. So remember, you definitely don't have to have one. Just depends. So when the degree of the top is bigger, there's none. Vertical asymptotes, this is where we want to factor everything out. And so here, this would multiply to a -5 and add to a -4. So it would give me x minus 5, x plus 1, and then my denominator I don't have to do anything with. So notice that nothing cancels out. It doesn't make, a whole makes the numerator and the denominator equal to 0. Vertical asymptote just makes the denominator equal to 0. So there's nothing here. So I just need to solve for this x minus 3. So if I say, well, what minus 3 equals 0, that would obviously be 3. And so I know I'm going to have one at x equal 3. So I've got that one there. There's my kind of boundary marker. So now whole. There are none here, as we just found. And slant asymptote, that only occurs when the degree of the top is exactly 1 bigger than the bottom. Well, I have that. I have the degree of the top is 2, the degree of the bottom is 1, and that's the exact situation where a slant asymptote. Slant asymptote is also known as an oblique asymptote. And so what that means is I have to be able to basically divide this and see what I get. So I'm going to have to do this. Now, luckily for us, we can use synthetic division because I have an x minus or an x plus something. That's the easiest way to be able to do it. So I'm going to kind of do this here on this next line. And so my corner number here is going to be a 3 because that's the opposite of that plus 3. And then I'm going to have a coefficient of 1, -4, -5. So 1, -4, -5. And so then we'll just kind of follow the pattern that we used to do. So this one's just going to drop down. So I'm going to take this 3 times 1, that's 3. And then add down to -4 plus 3 gives me -1. And then I'm going to multiply this corner number 3 times a -1. That gives me -3. And I add down and I get -8. So the nice part about slant asymptotes is we only care about this. So this is 1 degree less. So if this was the first one's a quadratic we're dividing, then this is just going to be an x minus 1. Now, for us, that slant asymptote is going to be this. In the long run, this will be negligible. And the basic reason why is if we divided that out, we'd say, hey, that's x minus 1 and then -8 over x minus 3. So as my values get really, really, really big, my denominator is getting really big. Anytime your denominator gets really big, that's trending to 0. Because like 8 divided by 100 or 8 divided by 1,000,000 or 8 divided by 1,000,000,000, that's getting closer and closer and closer to 0. So what this means is this part's negligible because when a slant asymptote occurs, values are going to eventually get closer to it as x is getting really, really, really big. And when x is getting really, really, really big, this fraction's tending to 0. And again, the reason why is if you do 8 divided by a super big number, that's really 0 once you get there. So my slant asymptote is y equals x minus 1. So that's in this case, a slope and y-intercept of -1. And then I'm just going to go up 1, right 1, up 1, right 1, up 1, right 1. And I could also go down 1, left 1, down 1, left 1. So that's what your slant asymptote is going to kind of look like. So x and y intercepts. I can do this like before. I'm going to basically take the numerator. So the numerator, when I had a factor, is x minus 5 and x plus 1. So x minus 5 equals 0, x plus 1 equals 0. And so then that's just going to give you x equal 5 and x equal -1. So that means that the coordinate points of 5, 0 and -1, 0, that's going to be a part of my graph. Y-intercept is when you set the whole thing equal to anything where you see an x equal to 0. So I'm going to set this whole thing equal to 0 there. So then that'll give me 0 squared minus 4 times 0 minus 5. And on the bottom, you'll get 0 minus 3. And so that'll just leave you with your constants. So then you get 5/3. So then not quite, this will be 0 5/3. So not quite 2 on that case, just 1.6 repeating. And so if I go ahead and graph this one, so we're going to make a dot here at 5 because that's one there. And then we know down here we got a -1, so make a dot there. And our y-intercept we said was going to be 0 and not quite. In this case, we said our 0 was going to be 0 and then 5/3. So something along those lines. And so now once we kind of look at it, what our graph's going to look like, we're going to kind of have to see, what Desmos tells us. And so if I kind of look at this type of graph, it gives me looking like that. And so, yeah, so we kind of go back. Oops, mistake here, went down. That's supposed to be a positive 5/3. So my dot's going to be up here. So that'd be 5/3, not down there. And so then it'd be up here. So what this graph is doing is it's kind of curving this way, getting close to this, hitting this point, and going up. This one's going to kind of come the opposite way. And if you wanted to find more values here and say, okay, well, what happens at 6 or 7 or 8 or 4, we can definitely do that. So if I want to happen at what happens at 6, you can set this up with function notation. If you set it up and then say, what's f of 6? Well, f of 6, that means your x value is 6 and your y value is 2.3 repeating. So here at 6, I can go up here to 2.3 repeating. It's about there. And what happens at 8, for example? I can do the same thing. So when my x value is 8, I'm at 5.4. So that's going to be 8, 5.4. You can kind of see that this thing's going to trend this direction. And same with this one. This one's going to kind of go up here, hit those 2 points, and looking like that. And it looks exactly like what our graph is. All right, let's do one more. So same situations, we're going to find our horizontal asymptote. So degree of the top is 2, degree of the bottom is 1. These are leading coefficients of 1, so it's 1/1. So my horizontal asymptote is 1. And then that'll be looking like this. My vertical asymptote, we're going to factor the top and the bottom. So up top, I'll have an x plus 3, and then an x plus 1. So it multiplies to 3, but it adds to 4, so that's going to be 3 and 1. And then down here, I've got it multiplies to a -12 and adds to a -1 because we know that this is going to be a 1 there. And so then that'll give me x minus 4 and x plus 3. And so what I know here is that these are going to cancel because it's the exact same, which means there's a hole at -3 comma something. So that's a coordinate point. So I know I have a hole at -3 comma something. I just don't know where the rest of it is until I can find it. Now this one, x minus 4, doesn't cancel out, so I know that there's a vertical asymptote there. So I get x minus 4. So then, or equals 4. So I got that. Now the rest, to be able to figure out what else is going on, is we're basically going to have to cancel these guys out for now. And then that leaves us with x plus 1 over x minus 4. So when you have a hole, this is where you're plugging in this value right here. I got to take that -3 and plug it into the top and plug it into the bottom wherever you see an x. So then that would give me here -3 here, plus 1, and then -3 minus 4. And so then that would give you a -2 over a -7, which is 2/7, and that's about 0.3. So there's a hole over here at -3. So 1, 2, 3, and then 0.7. And so -1, 2, 3, and then 0.7 is about there. So I'll just draw an open circle there to kind of represent that. Slane asymptote, there's none. That occurs when the degree of the top is exactly 1 bigger. That's not the case. They're the same. X-intercepts, that's when you set your top and their bottom equal to 0. Now, this one, -3, that's not there because we said that that's a hole. So even though I solve for it and I get it, that's not a part of my domain because a -3 would make the denominator equal to 0, which means that's not a part of its domain. But the other one, x plus 1, if I set that equal to 0, that'll give me -1. So I have one at -1. And so then that's -1, comma 0. So I know I'm going to have it there. The numerator, you're going to plug in zeros here. And we learned kind of last example that this is going to go away, this is going to go away, this is going to go away, and it's just going to leave me with 3 over and then a negative 12. So here I'll have 3 over negative 12. And so I can go ahead and kind of graph those different points that I've just made and be able to kind of see what my graph will essentially look like based upon what those points are. And so that'll make it kind of nice to be able to see, based upon what your values, different things like that are whenever you have these different points that you can kind of graph. And so once I do that, we know that this is going to be, since that's 0.25, it'll be that. And so once I go ahead and graph this, I've kind of graphed everything as I found them. The x-intercepts are going to have one at -1, 0. So I know it's going to be -1, 0. My y value in this case, so in this case it was going to be a negative there. That's going to be a negative point that, so then that's going to be just about there. So we know that, based upon the other ones that we've seen, this thing's going to kind of go through here, go through the hole, and then probably go down here, and then that means these other ones are not going to, or they're going to kind of go up top here. So I have a good feeling that this is going to look like this. Now, just to confirm that it's probably up here in this kind of corner, this is 1, 2, 3, 4, and then what happens at 5 and happens at 6, we can use Desmos to help us out. So over here, so let's say I call this one g of x. I'll call this one g of x. You have to define it with function notation first before you can use it. So g of 4 is undefined because that, in that case, with that vertical asymptote, we want to go past that. Well, g of 5. G of 5 is 6. So that means the coordinate point 5, 6 is on my graph. So my x value is 5, my y value is 6. So comma 5, 6. So that's up here. And we can say, okay, what happens, at 6, it's down at 3.5. At 7, it's 2.6. So it's coming around like this. So this guy kind of coming around here and then going that way. And then this one, and we can look at the graph to kind of confirm that. If I turn it on now. So again, it doesn't draw the asymptotes, but you can kind of see it's hitting these x and y intercepts that we found. And it's kind of going that way. And notice it doesn't graph a hole. So if I go through the hole there, right there at -3, it said it was undefined. And so that's what that one's talking about right there. -3 is undefined because it's a hole.